this is where we left off last time. So again, what we're going to do today is as we go through, if you struggle a little bit as far as finding how do they relate to one another, you're more than welcome to look online, and Google Classroom is where this will be at, next to the syllabus and whatnot, showing what today's day 6 was covering. Okay? So, one thing, when you come back from the 4-day weekend on Wednesday, we will do 3 questions maybe for review type for the quiz that you will have on Wednesday. Okay? For the rest of the period, we will review because we decided to do the test on Friday. So the test will be on Friday. It won't be the week after that after all. So we're not going to start the new unit. We'll just finish this one. We'll review on Wednesday, and the test will be on Friday. Any questions in that regard? Okay. All right. So the formula chart that you have, everyone should have this formula chart here. Go ahead and take it out today because you're going to use it a lot. And yes, you can write notes in it and whatnot. As far as how are we referring to each piece of the ellipse and each piece of the hyperbola and how they are similar and different. All right, so let's go ahead and begin where we left off last class. We're going to look at the equation of the ellipse and we're going to transfer it to general form. Okay, so let's start off. General form, what are we talking about? What are we trying to do whenever we're doing something in general form? Anyway, what are we doing? Yeah, you're gonna FOIL out the square pieces, but basically when we're getting it in general form, we're trying to simplify to set it equal to 0. Okay? So what we have right now, this is just algebra, basic algebra as far as manipulation. How do we begin to start doing this with what we have? What could we start off with to simplify to set it equal to 0? Common denominator. Yes, we're going to look at the denominators, but we're not trying to get them common, we're trying to cancel them out. Okay? So let's go ahead and cancel these denominators out by multiplying everything by what? What could we multiply everything by? Our goal is to get rid of denominators, just like Saeed's saying. We're trying to get rid of denominators. So what could I multiply all of these out so that all the denominators cancel out and I wouldn't have any more denominators? Do you see it? 16. Yeah, so the LCD is 16. So let's go ahead and distribute. The 16 and the 4 will become what number? Go ahead and speak up, guys. The 16 and the 4 will become what number? 4, yeah? So we'll get 4 is multiplied with x plus 1, and when we distribute with the second piece, what will the 16 and this 16 end up becoming? 1. So we have y minus 2, whoops, y minus 2, and it's going to be squared, and that coefficient is now 1. And what's my last term over there going to be with a constant? 16. So, yes, I've gotten rid of all the denominators. My denominators are 1, and now it's ready to be FOILed out as far as these quadratic pieces here and here. What shape do you see right now? A circle? It kind of looks like a circle. But what number up here prevents this from being a circle? Can you tell me? The 4. What typically do the numbers that we've worked with circles, what are those numbers usually? 1. So the coefficient already, and you can think about it in parametric form, the parametrics that we've done before, as far as the cosine piece, as far as the sine piece, the radii that you had here and here were the same as far as for circles. Because they're not the same here, that's another way that you could see it in this general form, that this is not going to be a circle. Okay? So, so what are we doing from here? If this is not a circle and this is an ellipse, what are we going to do from here as far as to manipulate and to distribute this out? We're going to go ahead and fold these two pieces out. And tell me, what do you get with the x squareds? What would this FOIL out to be? I'll write it to the side. What would I get here as we simplify this out? Right here in parentheses. X squared, keep going, plus 2x, keep going. Perfect. So So we have 4 times this that's going to distribute, and all we're doing is basic folding or distributing after that. So you get 4x squared plus 8x plus 4, and anyone, what would I get y-wise? Y squared minus 4y plus 4. Yep. And then you have 16, and here you're just going to distribute a positive 1 so that you have the following pieces set equal to 16. Is this standard, or sorry, is this general form? Am I done? I'm almost done. I'm almost done. What do I need to do at the very end? I need to get it set equal to 0 and get all my variables pretty much just grouped together. So grouping your x's together, you get this. Grouping my y's together, we'll get this. And now by adding these 8s and subtracting the 16, what will we have left over set equal to 0? Negative 8, yeah. So this right here is our standard form, and that's what we have as far as just the manipulation of the original piece. All right, so let's move on to going the other way. So we have ellipses, and now what we're trying to do is we're trying to change this standard form to standard form. So the general form is going to go to standard form from this equals 0. Now there's a lot of manipulation here. There's a lot of algebra that you're going to do, and there's a good representation of this on the test. Okay? As far as what pieces you're going to complete the square with, the coefficients with the x squared and y squared terms, and so on and so forth. Okay? So, let's go ahead and look at this. First step, let's group all of our x's together, and let's group all of our y's together. Okay? We leave a space, and we're going to set it equal to, let's see if you remember, what are we going to set it equal to right here? Not 50, but
50.
Not yet. Not yet. Let's going to set it equal to a negative 48. Right?
Yeah, yours is just different.
Mine is different?
Yeah.
Mine looks the same.
Mine's the same as
This is the
mine.
papers from the last time. Yeah, it's not the
Oh.
Okay.
coefficients.
Yeah, this is the papers from the last time. This is not from what you grabbed today. We will continue with what we have today. We're just finishing up the notes from the ellipse from last class. Okay. So, where they're standing right now, the completing the square piece is taking the b coefficient divided by 2 and squaring the piece. Can you see and can you tell me, am I actually ready to do this step right here, right now? Yes or no? I'm not. What up here tells me that I'm not yet ready to do this? The coefficient right here of 3. Okay? So I'm just going to complete the square on the y's, on the x's, and then I'll do it on the y's afterwards. But a good way to do that, so that you don't lose track of what you're doing, is to actually Gcf out this 3 from both pieces. You tell me, what do I have left when I divide 3 out from those y pieces? Y squared plus 10. Okay, I'm going to leave a piece right here for the completing the square, and now for the b, I can complete the square because the coefficient's 1. So I'm going to have x squared minus 6x. Can someone tell me what goes in this box right here for the b over 2 squared piece? Plus 9. What would go over here in this box? Plus 25. Here we go. How much did I add to the left side of this equal sign in the x? I added 9. Be careful. How much did I add over here in the y's? 75. I actually added 75 because you have to multiply by that coefficient. See, over here the coefficient was just 1. That's why it's just adding 9. But over here we're going to add 75. And with your calculator, please, what would negative 48 times 9, or sorry, plus 9 plus 75 give me? What do you all get? Say again? 36. Okay. So, What goes here for parentheses for my x? I'm completing the square. Remember, we square root, we borrow the first sign. What do I get? X minus 3. How about y? What would go inside the parentheses for y? Close. Y plus 5, yep. But right now, this is actually wrong because it's missing something. Can someone tell me what it's missing? Say again? The 3, right? So we got to be careful that when we're doing this, that we're keeping track of all of our pieces. This 3 actually is still here. Now, an ellipse, like we learned last time, what is it always going to be set equal to? An ellipse, and today you're going to learn a hyperbola. They're always set equal to what number? 1. So I need to divide everything by this 36, because my goal is to get this to equal 1. Then it's in the ellipse in standard form. So I have x minus 3 squared over 36 plus y plus 5 squared over 12 is equal to 1. Remember, the center, we're going to look at the center from here and here. And what does my center look like it's going to be? 3, negative 5, yeah. Because it's always the opposite of parentheses. What's the a value? 6. What's the b value? What would the b value be? The square root of 12. Guys, in your formula chart, I'm going to tell you right now, x, y, it's in alphabetical order, and the way they line up is a, b. So if you see an a in any equation, it belongs with the x. If you see a b with any equation, it belongs with the y. And in the equation that you have, this is a squared, and this is b squared. So if I square root 12, I get root 12. What I would like for you to do on your test, though, is remember that 4 times 3 is 12, so that you can actually square root that 4 out as a 2, and write this as 2 root 3. Okay, simplify it all the way. All right, let's move on to the next one. Get a little bit more practice. Step 1, we're going to group all the x's. Here we go. So 30x, leave a little bit of space. Now we're going to group all the y's. 2y squared minus 8y, leave a little bit of space. And we're going to finally set it equal to, can someone tell me what? 27. Yeah, because you moved it over to the other side, and it became a positive 27. We're going to GCF out, we're going to GCF out the coefficients. In this case, it's going to be 5 for the first one. It's going to be 2 for the next one. Let's see what we have left. We have x squared plus what? Plus 6x. Leave space for the completing the square. And then we're going to have what over here? There we go, nice. And then over there, we're still going to have our 27 that we haven't touched with right now. Okay? I'm about to do b over 2 squared. That's that completing the square piece. And I can do it now because the coefficient of x and y are what? 1. So can someone tell me what's going to go in this first blank right here? 9. How about this one over here? Plus 4, right? Because 4 divided by 2 is 2. Square that is 4. Because the b term is whatever's in front of this x and whatever's in front of this y. Remember, it's b over 2 squared comes from the standard form of the quadratic. So if you looked at where just the x term is at, we're looking at the coefficient of that. Okay? Which is the same as the y term. Okay, so this x squared plus 6x plus 9 is going to become what? X plus 3. Don't forget the 5. What's this y squared business going to become?
Y minus 2.
Yep, y minus 2. Don't forget this 2. And then we have 27. But I haven't done it yet. I should have done it the last step. How much did I add xy's? 45. How much did I add yy's? 8. we're going to write that over there. And those of you handy with the calculator, what is that? 35, 70, 80? Is it 80? Okay. So we get 80 right here. And now I just have to make sure that, what do I do next? You can move back if you want. I just got to divide by 80. So dividing by 80 gets me to this. So I'll get x plus 3, that 5 and that 8 reduced to what? 116? And the y minus 2, that 2 and that 80 reduced to 40. And then I get this. So that the center is what? Yep. What's the a value? 4. Because a is with x. What's the b value? Square root of 40. Which, look, watch this. We're going to do 4 and 10. And then we're going to be able to pull out that 4 as a 2. I can't factor the 10 anymore where I can pull out a root. So I'd want you to write 2 root 10. Okay. So now we're going to pick here and there as far as all the examples that we're going to do, because we don't have enough time per se to record and do every single example. But I want to make sure I get a good representation for the quiz and for the test. Here we go. The first one, we're going to find the center. We're looking at these equations. Of course, these are the pictures of the equations. Can anyone tell me what the center is for the first one? 0, 0. How about the second one? 0, 0. And the third one? 5, 3. And again, we looked at that because we were looking at the signs, otherwise the opposites of what was inside the square pieces. Okay? What's A for the first one? 5. And B? 4. How about the second one? What's A? Square root of 11. And then 6. How about number 9? 5 and 3. Okay? So make sure that you remember that A is with X. So I'm going to move 5 units, and that's how I'm going to know where to draw the end of that ellipse. So this root 11 is that, and this 5 units is from the center. That long piece is going to be 5. B is with Y, so I'm going to go up or down 4 units, then up or down 6 units, and then up or down 3 units. That's how you know how to draw them. Yes?
So the A and B's are always positive?
The A and B's are, yes, they're always going to be positive. Nice, because you're going to square those pieces, so it's going to be positive anyway. Okay? Alright, so big thing with the ellipses are they are actually adding, and because they are adding, a good way to know what to do without. So I usually teach this so that students are memorizing this, but I actually kind of want you to half memorize what to do. And a good way to remember is because ellipses are adding, when we are looking for their C, we're going to be subtracting. Okay? And what we do is, with the ellipses, it's all about which number is bigger. Look, this one's bigger. That's why it's a horizontal ellipse. This number is bigger, and it's with the Y. That's why it's a vertical ellipse. Okay? So this number is bigger. It's with the X. So size matters on this ellipse. And that's the way I kind of want you to memorize that. Look at the size. It will tell you what it's going to look like as far as the equation is concerned. Okay? So, because they're adding, let's go back to C. We're going to subtract. Which one's the bigger one? Is A squared the bigger one, or is B squared the bigger one? And this one, A squared, is the bigger one. So it's going to be A squared, I'll write it over here, A squared minus B squared. We're going to take the square root. So this A is the bigger one. Again, that size matters, kind of interpretation to get C. If you are a little nervous about getting the wrong answer, because some people did it earlier in 6th period today, put an absolute value. So that if you did B minus A, if you took the absolute value, it's still going to give you the same thing. Okay? Alright, so A for this one is 25, or A squared is 25. minus 16, and we're going to take the square root. That'll give us C. What's that going to be? What does C equal? Well, 25 minus 16 is 9. Take the square root, you get 3. So here we go. 3, this is important, is the jump from the center out. Either left and right, or from the center out, up and down. You with me? Because size matters on this, which directions are we going to jump out with the center? We're going to jump out left and right. Okay? So that jump of 3 will tell me right here is where the foci will be. 3 units to the right is one of them, and 3 units to the left is the other. So what do you have? Negative 3, 0 for one, and 3, 0 for the other. You with me? And some of these notes are a little bit off on the one that's on Google Classroom. I'm going to make sure that you know that. I think that might have been the first one that was off. So there's a couple numbers that if you go back, I think Ms. Hamilton just mistakenly put 0, negative 3, and 0, 3. Okay, so just make sure that you understand what's the correct answer. E is equal to C over A. C is 3. A is 5. So the eccentricity on this is 3/5. Okay? Let's come over here. We're going to do the same thing. I'm going to go through it, and then let me know if you have any questions. C is the square root of the bigger one squared. So that's 36 minus the smaller one squared is 11. 36 minus 11 will give me 25, and if I take the square root, C is 5. So 5 units jumping up and down, because the bigger number is with y, is going to get me here, and it's going to get me down here. A little bit more. So positive 5 and negative 5. And those points are going to be 0, 5, and 0, negative 5. Eccentricity is still C over A. And C is going to be 5, and A is going to be root 11. And if you do that with your calculator, tell me what you get. What do you get as a decimal? Actually, I think I might have. It's not divided by 5. It's divided by what? Or it's not divided by root 11. Sorry, it's divided by what? 6. So this root 11 in your calculator, root 11 is smaller than 6. Okay? So because that size matters, we're going to divide it by 6. So that we get 5, 6 is the eccentricity for that one.
So E isn't always equal to C over A, like it can be C over B?
It can be C over B, yes. Okay? Any questions? That was a really good question what he just asked. Is it always C over A or is it C over B? It's basically E should be for ellipses, C over, which size matters, right? The bigger one. A or B, whichever one's bigger. So there's my eccentricity. So over here, if we were to do C, the bigger one squared is 25, the smaller one squared is 9. So C is the square root of this. 25 minus 9 is 16. Take the square root. The C is going to be 4. So I'm going to jump 4 to the right and 4 to the left. So that I get 1, 3, and 9, 3. Whoops. 9, 3 is the other foci. Okay? And again, just like Gabe said, we're going to do E is equal to C, which is that 4 that we solved, over the bigger one. Okay, so the bigger one between A and B is 5, so it would give me 4/5. So the eccentricity is 4/5. One last thing, just so that you can see whether you're doing it correct or not during the test, what do you notice about the eccentricity for ellipses? They're always going to be less than 1. Okay? For a hyperbola, E is always going to be bigger than 1. And what shape do you think E will equal 1? parabola. Okay? The parabola. And that was like from that 4AP is equal to 1. There's that equal 1 piece saying as far as with parabolas. Okay? All right. Let's look at the ellipse here. Okay, so we're going to do this one. We're going to do this one. We don't have time to do all three of them. What's the center of the first one? 0, 0. Can you see the A value right now? Because you know A is the same as what value? X or Y? X. So this is A. So A is what? 10. B is this. Do you know B right now? Nope. But you do know C. C could either be here or the same distance this direction. So C is 7. Okay? Ellipses, again, they add. So to solve for C, it's going to be the bigger one squared minus the other one squared is equal to C squared. Okay? So you could say C squared is going to be, which one's the bigger one? A or B? A. So we're going to do A squared minus the smaller one, which is my unknown. And I know that C is 7. So I can go ahead and write 7 squared. So 49 is equal to 100 minus B squared. If I move the 49 and if I move the B, I get B squared is equal to 51. So B is the square root of 51. Okay? All right. So now let's go to the equation for an ellipse. The equation for an ellipse is going to be the x terms over a squared. And right here what we have x squared because 0 is the x value. So there's nothing in parentheses there. And a squared is going to be 100. It's always plus y squared over what? 51. Sure enough, there's my equation. So fairly easy, some of these. Let's look at this one over here. It can get a little bit more involved where you have to think and make sure that you're understanding what you're looking for. Okay. Do I know my center? Yes or no? 0, 4. Nice. Because he knows 0 to 8, halfway would be the center. So this is 0, 4 right there. Which of the three letters do you know? A, B, or C? B. What is B? Not 8. So that is a common mistake. It's not the entire major axis. It's just half of it. So this is going to be 4, and B is with Y. That's why we went up and down. Do we know C? We have to find it. We know E is equal to C over B, because the bigger one is B. So we'll say C, which we don't know, over B, which we do know it was 4, is equal to what they give us of 1/2. Now if I multiply both sides by 4, I'm going to get C is 2. So now that I know C, I can go back and find A. Okay? Which one looks bigger right now? The A or the B? The B. So we're going to say B squared minus A squared is equal to C squared. All I did was plug in the numbers that we just saw. So we'll get 16 minus A squared is equal to 4. And if I move the A over here, move the 4 over here, I get 12 is equal to A squared. So A is root 12, which is 4 times 3 that I would want you to write as 2 root 3. Okay? So the center was 0, 4, so we have x squared, and we have y minus 4. These are my numerators. We know it's equal to 1 because it's an ellipse, and now, what goes underneath x squared? 12. And what goes underneath y squared? 16. And that's how you would get that one. Okay? Okay. So now let's move on to the real world application. I'll tell you right now, the bonus question that you have on the test will come from some type of real world application. Whether it's the parabola, like the flashlight kind of stuff, whether it's this right here, it will come from some kind of real world application problem dealing with any one of these four shapes, okay? Here we go. So, Judd, if you can forward me that email, that video, I want to share that on Remind with other people, because I told sixth period about this that you did in New York, of how he was in Grand Central Station, at the train station, whatever, and he's in a corner whispering into a corner, and someone who is in another corner way across the way, even though there was people walking across, he recorded, and you can actually hear that person talking. And it's because of the architecture of those arcs that the sound was just traveling. It's actually pretty cool. So these are called whisper rooms, and there are two foci right here and here to where it's saying that you could speak clearly, like let's say it was here, and it would travel all the way back to where the other person could hear you in a sense. Okay? And that's the way the whisper rooms work. But they're more so like the ellipses are traveling things like this. Okay? But the architecture will let you hear things. And acoustics is another application. You know, people who design, like, whether it's just concert halls, whatever, the way they're shaped, the acoustics that they have so that there's no dead spots. If you're in a movie theater, how do they create those sound fields so that you're not missing something that's kind of surround sound? It all revolves around this kind of stuff with the architecture and whatnot. All right, so suppose we have an elliptical room that is 70 feet long. Okay, that's that, and then we have the 40 feet long vertical axis. What we're trying to do is locate the foci. We're trying to locate where would these points be in a real-world application, because those would be the sweet spots, if you will. Okay? So the way we're going to start this is we're going to determine that this center is right here at 0, 0. Let's call that the origin, per se. Okay? So if this is the origin, we'll say the center is 0, 0. Can someone tell me what A and B would equal if I made that the center? What would A equal? 35. Okay, because 35 is that horizontal distance with X. What would B equal? 20. 20, right? Because it's going to be half of that. So this is an ellipse when I know that they are adding equaling 1. So C will come from taking the difference. Otherwise, the opposite of what this is. So it'll be bigger squared minus smaller squared. So bigger squared would be 35 squared minus 20 squared. And when you do that, 35 is 625 minus 400. Take the square root, we get C. So what is, no, I'm sorry, it's not 625. My apologies. It is what? 1225. So if I did that, I would get 825. Take the square root. C is going to be approximately 28.723 feet. So find the focus by measuring 28.723 feet to the left and to the right of the center. Those would be where the sweet spots are at. So this distance would be from the center. That's where the foci would be located. Do we understand? Okay. All right. Our last shape, guys. Okay, before we get to it, just showing you eccentricities are less than 1 are all ellipses. Okay. Then we're going to go to the hyperbolas. Here we go. The hyperbola looks something like this. Notice if I make A bigger, what is happening right now? And if I make A smaller, what happens? And then it flips on its axes. Okay? The big thing is knowing this. If A is, let's say, 1, and B is 3, well, right now, the one that I'm graphing, whoops, is this one. Okay? On ellipses, I helped you out with size matters. On hyperbolas, it's order matters. And order matters because subtraction, order matters. You with me? 1 minus 3 is not the same as 3 minus 1.
So the way I'd like for you to remember how it's going to look is whatever's listed first. Otherwise, whichever one is the positive term, that's where it's looking. So y, it's looking up and down. You with me? Because if x was listed first, otherwise, let's turn this one off and turn this one on. If x was listed first, now this right here is the positive version. Okay? So if this is now the positive version, you can see that the positive x is going to be here and here, looking left and looking right. Okay, so that's a good way to recognize which one's which. So as this grows, you see how it's changing out. Let's say that we put it at 2, and let's say that we put b at, let's do this one 2 actually, and let's do this one 3. Let's do that. I'm going to show you a cool relationship that exists, that visually if you see it, it's a lot easier to understand than looking at all these equations, okay? If I were to ask you where the center is, what would you say the center is at? Origin. What would you say the A value is? 3. Nice. That's this right here. What would you say the B value is? 2. Well, duh. That's what. So 3 and 2 right there, right? So B is 2. And that's going to be up and down 2. And guys, look. I'm trying to create this. 3 goes to the vertex. B would go to the y value. And now what I'm going to show you what's so important about these these 2 points is this. I'm going to create a box with those points as if I was going to the left and right that many units. So it's going to look something like this. See if it'll land. Almost. So here's that box. There's the vertex on the right. And here's the vertex on the left. We're going to go up and down 2, left and right 3. What's the point of the box? The point of the box is this. I can draw a line through here that looks something like this. Think of it like a slant asymptote, the way we did slant asymptotes a while back. Okay? So let's go here. And it's going to have a slant asymptote, almost had it, that looks something like this. Then we're going to have another one that comes from here and looks something like this. So let me line them up, make sure that they're, the struggle is real. Alright, so we'll do it like this. Maybe. Maybe. Come on, come on. Is it doing it? Is it doing it? Yes, it is. Okay. Alright, so let's see if I can. Oh, come on. Come on. Alright, there you go. So, what are they for? They're the asymptotes that the graph will approach but never hit per se. Okay? So that's where this graph, the hyperbola, is going to come out, and it's going to come to where this is the vertex, this is the vertex, and then we still need the foci, which is over here. Otherwise, the light bulb of these, they could be seen as parabolas, okay? Which would give me this value here. So from here to here is A, from here to here is B, but from the center all the way to the foci is C. Okay. Now, let's go to the equations and look at this with numbers and stuff so it's a lot easier to interpret. Alright. Here we go. Let's do our first one. Is that mine? Is that might be what? Okay. I think I might have done this from before. Did I do this from before? I did this from before. Okay. I just hadn't erased it. Here we go. Who can tell me by looking at this equation what the center is? What's the center? Negative 2, 3. Oops. And I got that from looking at the x and y pieces and interpreting the opposite. Okay? So far so good? Alright. So now let's look at what's A. 4. What's B? 3. Okay. Hyperbolas are subtracting, guys. So to solve for C, what are we going to do? We're going to add. So C squared is always going to be the opposite of what this equation looks like. So in this one, it doesn't matter because you're adding. So it can be A squared plus B squared or B squared plus A squared. So let's do A squared plus B squared. So A squared is 16. B squared is 9. So C is 5. Yeah?
Why did you say we were adding?
Because it's just the equation that you do to solve for C with a hyperbola is we know the standard form is subtraction. And a good way to remember it's just going to be the opposite. You're going to add over here. Okay? Now, 5 is this jump that'll get me from something to the foci. What's that something? I'm going to jump from here to the foci. What's this? Not the vertex. A lot of people think so because they are thinking parabolas. It's jumping from the center. From the center of the graph. So the center of the graph we saw was negative 2, 3. That's right here. Okay? So now I'm going to jump this much. Which directions? It's either left and right or up and down. Which one is it going to be for this particular equation? Left and right, because the x term was positive. So it tells me that it's going to be a horizontal hyperbola. So if I jump 5 units to the right, 1, 2, 3, 4, 5, there is where I'm going to graph this foci. Otherwise, focus. Focus is singular, foci is plural. So 1, 2, 3, 4, 5, there's the other focus. You with me? So I jumped left and right 5 units from this number. That would give me, let's say, F1 and F2. Let's call this F1. Let's call this F2. What are the coordinates for F1? Negative 7, 3. What are the coordinates for F2? 3, 3. Okay? And the vertices, who can tell me what the vertices are going to do? It's like, where do you get the vertices from? 2, 3. How did you get 2, 3? You're right, but how did you get 2, 3?
It's the middle of the outside of the box.
So it's right here.
Yeah.
It's right on the box, yeah. Let's say you didn't draw the box, because you're either going to do it or you won't on your quiz and test. Let's say you didn't draw the box. How could you know that one of the vertices was 2, 3, guys? Well, the center is negative 2, 3. It's right here. X-wise, yep, you would jump 4 units. And that's what would get you to that vertex. Y-wise, you would jump 3 units. And that does not get you to a vertex because there aren't 4 vertices. There's just 2. But it at least shows you where those lines are going to be for the box. And we'll get to that here in just a bit. And that's the last bit of what we're doing right now. Okay? So the vertices are going to be, this one right here we said was 2, 3. And what's this one way over here going to be? Negative 6, 3. Those are your 2 vertices. Okay? The last thing, last 2 things. I think this is I'll say this for the very last. Okay? Eccentricity. E is equal to C over what? So what you're going to do here is the other one, say again? So me ask you this. What was the one that we did as far as when Gabe was asking this, we said C over what for the ellipse? The bigger. Okay? So for the hyperbola, where it's not whether size matters, it's more order matters. C is going to be over what for the hyperbola? Well, there's two. There's one of you is saying A and the other one's saying B. Doing A, what would A give me? Where's A? A is going to give me what? So C is 5, and A is what? 4. Let me find it just real quick so I don't accidentally say something mistakenly. X minus 3. We get 4. So E is 5 over 4. A 1. Will it always be A in the denominator? If it's a horizontal, that's what you put down there. You with me, guys? So the way Gabe helped us out for the last one, that the bigger one went down here, Evelyn's helping us with recognizing it's the one that's listed first. That's the one that you're going to pull that number down and put it here. You with me? So if it was like y squared over something minus x squared over something is equal to 1, this number, the one that's under y, would be the one that we would put there, which in that case would be C over B. Okay? And 5 over 4 is bigger than 1, which we talked about earlier. If it's bigger than 1, it's going to be a hyperbola. Okay? So that's why, to me, that's why I try to help you out with size matters and order matters. You got to see this a couple times, so we'll do a couple more so that you can get it really, really well, and you should be good to go. All right, so eccentricity is 5/4. It is bigger than 1, therefore it verifies and validates that it is a hyperbola. All right, last thing that we need to do is this. We need to come up with equations of these lines that are called slant asymptotes. This one right here, and this one right here. And the equation comes from y minus y1 equals m times x minus x1. This is what we were looking at as far as in Algebra 2, point slope formula. Okay? So let's look at this. This right here, this x and this y, are in fact the center. Okay? We know that x is -2, so we're going to put over here, we're looking at identifying it this way. What's x minus a -2? Well, x plus 2. And then it's y minus y1, which is y minus 3. Now we just need a plus or minus slope. And this is the last bit of piece that you have to learn, and we'll practice a little bit more. Okay? Slope is rise over run. Otherwise, y over x, tangent. Otherwise, b over a. So if I looked at b over a, it would be a positive 3/4. Do you understand? And look, that makes sense, because if I come over here, I can see that my angle is going to do this, look, or my slope. Up 3 over 4. Up 3 over 4. Up 3 over 4. So on and so forth. You with me? And there's a positive, which was this one, and there's a negative, which would be the -1. Guys, that's it. Those are all the pieces of a hyperbola. Okay? So let's do a couple more examples and then we'll call it a day. So there are answers right there on that one. And you can pause the video when you see this video, or you can just go on Google Classroom, but I want to work some that are blank together, answer any questions, and go through pieces that you still have questions over. So we have these two. I'll let you choose a couple. We have these two. We have this one in general form. And then we'll change this back. So we'll do one of each of these. We won't do this one, okay? We won't do that one. Or we can. We'll do one from each side and then we're done. These go fairly quick. Okay? Here we go. What is the center? Or let me ask you, do you want to do this one or this one? The first or the second one? The second, okay. Here we go. So this one is going to be, what's the center? 0, 0. What's the A value? 1, 2, 3, 4, 5. What's the B value? 2. So the vertices, guys, remember the vertices are the points on the graph of the pieces of those parabolas that are going out for each one. So what's the top vertice? 0, 2. What's the bottom vertice? 0, negative 2. And again, we knew that because it was vertical, and vertical is B, so we jumped from this point up 2 and down 2. Okay? Now, a hyperbola is subtracting, so how do we find C? C squared equals A squared plus B squared. Yeah? So A is 5, so that's 25. B is 2, so that's 4. So C is going to be the square root of 29, which is a little bit over 5, if you will. Okay? So, I'm going to go what directions from the center this much? Up or down? Up and down, or left and right? Up and down. So that I would be here and here for the foci for each one. Okay? So we have root 29. Now, if I go up root 29 from this, I would have 0, root 29. If I go down, I would have 0, negative root 29. Okay? Eccentricity. Evelyn and Gabe helped us out with this. Eccentricity will be C over the positive one. So what's the positive one? What is it that I'm going to put there as far as under in the denominator? The y, right? Because this is looking up and down. So it's going to be like y squared piece minus x squared piece. Again, because it's looking up and down. So y is this. Do you agree? So C over B, which in this case is going to be root 29 over 2. Is that bigger than 1? Yes, by a lot. So it validates and verifies that this is going to be. So you don't even have to do the graph. If you know A and if you know C, or if you know C and B, you know that it's going to be a parabola or a hyperbola, you know what I mean, or an ellipse. Okay, so E is root 29 over 2, and now we have the standard form. Okay, so the standard form is, you help me out, what's the x going to look like? Or let me ask you this, which one gets written first? Y. So let's write that fraction. What is that going to look like? Y squared over what? Close.
Wait, no, 4.
4. Yep, because y is B, x is A. Right? Remember how we did alphabetically? X comes before y, A comes before B, so those belong together and those belong together. Okay? Then what? Y squared over 4, what? Minus x squared over 25 equals 1. Okay? The parametric form. Okay? So let's do the x. Let's do the y. And this is new. We haven't talked about this yet. The parametric form for a hyperbola is not cosine and sine. Okay? You have secant or tangent. Okay? And they're going to be secant t and tangent t. Look at this. This is my shortcut to you. Oh, not that. Secant almost looks like the word C. I kind of have sloppy handwriting that it almost looks like C. So think of eyes, right? As far as where is the graph looking? Well, the graph is looking upward and downward. So it's seen vertically. You with me? If it was horizontal, it would be seen horizontally. Because it's looking up or down, my secant is going to be with the y. Okay, so it'll be plus secant t. But there's a coefficient in front of secant. Okay, and the secant, yeah.
On parametric, does it matter which goes first, X or Y?
I'm sorry, say again.
On parametric, does it matter which goes first, X or Y?
It doesn't, but what's normal standard is x is on top, y is on bottom. Like y equals mx plus b, you could say y equals b plus mx, but normally it's mx plus b, just like normally this x is on top. Okay? Okay, so let's finish this one up. What number do you think is going to go in front of secant? Remember, secant is with y. What number would be in front of secant? 2, yes. So, what's the y value, the center of the y value? 0. So if it wasn't 0, it was like 5, 8, whatever, you would put that here, and it would be that number plus 2 secant t. Now, do I need this 0 here? I don't. Okay? I'll put it just for instructional purposes, and this x is now going to be the tangent piece. So what goes in front of the tangent? 0 plus what? Tangent of t. 5. Again, because 5 is x, otherwise horizontal, it's going to go over here. Okay? There's a lot. Good thing is you don't have to memorize all these equations, because getting students to memorize that is a different task. Oh, yep.
Are we doing the asymptote?
Oh, did I forget? My bad. Okay, yes. So let's do the asymptote real quick. It is, let me make some room right here. Again, it's y minus that y1, right? Otherwise, y minus k is equal to that plus or minus rise over run, otherwise b over a, of x minus h. Okay? The center is 0, 0. So that 0 is going to be here, and the y0 is going to be here. Just be careful with negatives on your test, please, because if it's x minus a negative, it's like adding, okay? So we get y is equal to x. Now you have a plus or minus, and you need to come up with a b over a. So b over a is just going to be 2/5. Done. Yeah. Yeah, it should be on there. Is it not on there? Yeah, it's on there. It's at the bottom. Guys, if you don't have one of these screen sheets, I will hand one to you before you leave today. And yes, grades are updated in Skyward completely. If you got an A, or sorry, if you passed the first test, those quizzes already have been replaced as well. Okay? And looking at grades, y'all look good right now. I mean, there's some people that are struggling that unfortunately were failing. I don't have a single person fail. Well, I have one person failing only because they were absent. They need to make up some work. They'll be fine. So let's keep going. We have a couple more. I'll pass everything out, so just hold tight. I'll pass everything out here in just a bit. Let's finish these up. Write the equation in the hyperbola that satisfies the condition. So we have foci, otherwise the light bulbs of these parabolas, at plus and minus 6, 0. So let's go ahead and draw that. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Those are the foci. Okay? So already we know they're going to look something like this. Okay? The vertices. The vertices are going to be, let's do this in red, plus or minus 2, 0. So now we know for sure that the graph is going to look like this and like this. Okay? So what we're going to do is we're going to figure out what this box is so that we can figure out like the slant asymptotes. What are those equations as far as those dashed lines are concerned? So it would look something like this. It would look something like this. But my ultimate goal is to get this in standard form. Okay? Which letter comes first, X or Y?
X.
X, because it's horizontal. So it's going to be X minus 0, right? You see that?
Yeah.
because the center is 0. So we don't have to put x minus h. We could just put x squared minus y squared because that y value is 0, right? So the center is 0, 0. Again, those values would have been in parentheses here as opposites. Okay? Do we know A, B, or C? Which one do we know? We know A. What's A? 2. What's the next letter we know? C. It's 6. So now B is going to be found from what equation? Nice, guys. Nice. Okay, so A squared is 4 plus B squared is 36. Subtract B is the square root of 32, which you can bring out as 16 times 2, which will come to 4 root 2. Okay? That's a little bit less than 6. So B is 4 root 2. Are we ready? Can we, what pieces we have right now, can we go to the equation? I mean, we can finish up the equation, right? What goes underneath x squared? A is x, right? So it'll be a squared. What goes underneath y? This, but squared, right? So that's 32 equals 1. Done. If, listen, a little bit more practice. If this was parametric, you'd have x equals, y equals. It'd be 0. It'd be 0. It's seen horizontally, so the secant is going to be with the x, and the tangent's going to be over here. Now we just have to figure out what are the numbers that go in front of these things. You see what I'm saying? What number would go in front of that secant, guys? 2, because it's always that a piece. Okay? Not a squared, but 2. What would go in front of the y piece? 4 root 2, or root 32. Nicely done. Okay? Alright, a couple more, we're done. So we're going to write this in general form. This is going to go fairly quickly. Okay, here we go. Multiply this by 16. We get x minus 7, because the 16's cancel. 16 over 4 will reduce to 4. And then you get 16. Then I would concentrate on distributing this to minus 10 plus 25, which you're still going to have to take this 4. This is x squared minus 14x plus 49, and then equals 16. The biggest mistake people will make right here compared to when they were doing ellipses is this right here. When you distribute this negative, please be careful that you distribute a negative times a negative is a positive. So negative 4 times y squared, negative 4y squared. Here we go. Negative 4 times a negative is a positive 40y, and then it's a negative 100 is equal to 16.
You have to add to the right side.
So there's no completing squares right now. So no, you're not going to add to the, that's a good question. Good timing. You're not adding anything over because you're not completing the square. There's no b over 2 squared piece going on here. You're just simplifying. Okay? So let's get all of our squared pieces in line. X squared minus 4y squared. Then we're going to get our x's and y's in line, which you get this and this. And then finally our constant terms, they're going to all move on the left side. So 49 minus 100 is negative 51, which we're going to subtract 16, negative 66, or 67. There's your standard form, guys. Easy enough, right? Whew! I believe we have, yep, one more. We're done. We're going to complete the square of what Gabe was just asking just now, and we're going to identify the center and the radii per se with this hyperbola. All right, here we go. Which one do y'all want to do? We'll do only one of them. 2 or 3? 2. All right. Group the x's together. Leave a space. Here's different. We're going to subtract the y squareds. Okay? And subtracting the y squareds is a little bit weird right now because you have this negative 14y. So that means I'm going to have to put it like this and put the negative 15 here. Look what just happened. I grouped these together. Okay, you ready? I grouped them together. And then I'm going to GCF out this negative by pulling out this negative from both. So if I GCF out a negative, it's going to become a positive. You see what I'm saying? So this negative 1 comes out, you're left with y squared plus 14y. And why is that the case? Because if I were to redistribute this out to go back to general form, I would get that negative 14 that way. That's kind of big right there. Okay? Any questions right now with what I did with that negative? You don't have to do that on the ellipse because it's adding. The signs don't change. That's a huge mistake people make. Make sure that you get a good start on that early. Well, web assignment's going to be due midnight on the day you come back on Wednesday, but I really, really hope that you guys are in here during Eagle Time on Tuesday asking any questions if you need help with. Okay, here we go. I'm going to GCF out the 4. Leave space for the squared. I'm going to already GCF'd out the negative. So I'm ready to rock and roll with this one. Equals negative 15. Can someone tell me what goes in this box right here? Plus 25. How much did I just add to the left? 100, right? I just added 4 times 25. Remember, you always do this if you have a coefficient bigger than 1. What's going to go in this box right here? 49. So what is it that I just did on the left side? Did I add 49? No. I subtracted 49. Exactly. That's where a lot of the mistakes happen, or with negatives in this unit. So someone do this in your calculator for me real quick. A negative, what, 64 plus 100 is what? 36? And now I have the x squared minus the y squared. Here we go. The first one's square rooted. Last one is 5. Borrow the first sign. Then y, borrow that sign, and it's 7. Just don't forget the coefficients if you have them in front of the terms. What am I going to do at this step right now? Divide everything by what? 36. Because we want to get this to be 1. So to be minus y plus 7, you guys have come a long way with your algebra. I'm not even kidding. And it's awesome. Okay, dividing by 36 with your y. And this is going to be what right here in your denominator? 9. Yep, because it would be divided by 36, would reduce this to 1/9. What's your center? 5, negative 7. What's your 8? 3. What's your b? 6. That's it. Nice job, guys. To y'all. So make sure you look at the video if you need to over the weekend. We'll have a quiz on the first day back after 3 warm-up problems.